So our first try it exercise in lesson 7, we're looking at polynomials. We're given a list of polynomials and we're asked whether each polynomial is a monomial, binomial, trinomial, or other polynomial. And then we're asked to find the degree of each polynomial. So with part A, we're given -5, just a constant. Let's go ahead and rewrite this with a variable. You can choose whatever variable you want because there's an invisible 1 there, which can be rewritten as y to the 0, x to the 0, whatever variable you choose to use. So that tells us the degree, where we wouldn't readily see that without it, other than knowing that it exists with any constant. So there's only one term in this polynomial. It's just an integer, and therefore this is a monomial. And we can see the degree on the exponent on the variable is 0, which means it's degree 0. Our second polynomial, there are 1, 2, 3, 4 terms. So it's not a monomial, binomial, or trinomial, because those would be 1 term, 2 terms, and 3 terms, respectively. So this is an other polynomial. It's already written in descending degrees of exponents on the y variable. So we look to the term with the greatest exponent, which in this case would be y cubed, 8y cubed, which means this is degree 3. Part C, there are 1, 2, 3 terms, which means it's a trinomial. And be careful here with this one because you might be tempted to go to this first term here because it has the greatest x exponent. But we're looking for the greatest total exponents between variables. Anytime we have multiple variables in the terms, we add the exponents. So this first term here is 2 plus 1, it's degree 3. The second term, there's 2 invisible 1s here, so it's degree 2. There's an invisible 1 here, so this is degree 4. So this last term here actually has the highest degree of any of the terms, and the degree of the polynomial is the degree of the term with the greatest degree. So this would be degree 4. 81m squared minus 4n squared. There are 2 terms, which means it's a binomial. Each one of these terms is degree 2. There's a squared on the m in the first term and a squared, or 2, for an exponent on the n in the second term, which means the degree for this polynomial is degree 2. And then part E, there's only one term, so that means this is a monomial. So since this is just one term, we add the exponents on all of the variables. So 6 plus 3 is 9, plus 1 is degree 10 monomial. So again, to find or to classify as a monomial, binomial, or trinomial, monomial just means there's one term, and the degree is the sum of all exponents on the variables. Binomial means so this is one term, this is 2 terms, this is 3 terms. Other polynomial would be anything greater than that. And then to find the degree for a monomial, you just add the exponents on the variables. And for anything other than a monomial, you find which term has the greatest degree by which monomial in the polynomial, which term has the greatest degree by adding the exponents on the variables. And or variable, whichever there is. If there are multiple variables, we add the exponents on them. If there's just one, it's just the one with the greatest degree. And then the degree of the polynomial is the greatest degree of any of the terms in the polynomial.